Hi guys, my name is Timapram Someshwar. I am from JNTU ECE ECE branch. I want to discuss about the graph through data structures. Graphs, a data structure that consists of a set of nodes and a set of edges that relate to nodes to each other. A set of edges that describes the relationship among the vertices. A graph defined as graph is equals to vertex comma edge, where vertex is equals to a finite non-empty set of vertices. Edge is equals to a set of edges or pair of vertices. For example, in the graph shown below, v is equals to 0, 1, 2, 3, 4, where edge is equals to 0, 1, 1, 2, 0, 3, this 3, 0, where edge is a point of x, y, coordinates, where vertex is equals to a point. Directed and undirected graphs, where undirected graph edge has no orientation nor no arrowhead, there has no direction. Directed edge has an orientation, that means one end to the another end have the direction. Weighted graph, that means the vertex have the weighted sum of the value. Directed graph, for the given above, there is a sum of the arrows from 1 to 2, 1 to 4 and 4 to 6 and 6 to 7. In the second graph, there is a undirected graph, there is no arrows and no direction are given below. Graph terminology. Adjacent nodes. Two nodes are different if they are connected by an edge. Here 5 is connected to 7 and 7 is an adjacent form. Path, a sequence of vertices that connect to two nodes in a graph. For example, 5 to 7, the 5 to 7 is a path. A simple path is a path in which all vertices are except possibly first and last are different. Complete graph, a complete graph which every vertex is a directed connected to the another vertex. For example, 5 is connected to 7 or 7 is connected to someone, for example 6, or 6 is connected to 5. So this is the complete graph. Here this is a 5 to 7. Here is not complete graph. A undirected graph, a connected is there a path between the two vertices. Here this is the two vertices connected to the 3. The directed graph are strongly connected if there is a path from one vertex to the another. Here that is connected to the 1 to the 2 or 3. Directed graph is weakly connected if there is a path between any two vertices ignoring direction. Here there is a graph connected to the one node to the another node. Here there is a directional graph. Here there is no directional graph, there is a weak end. Yes, complete graph has been edged between the every pair of the vertices. Here there is a connected to the two nodes of the vertex. Here this is the complete graph. For example, loops edges that contact vertex to the itself. Paths, sequence of the vertex P0, P1 or up to the Pm, such that each adjacent pair of the vertices are connected by an edge. A simple path is a path which consists of the except the possibility first and last and different. There are multiple edges and simple edges as graph properties. The number of possible pairs in n vertex graph is n into n minus 1. Since the edge the same of the edge, that number of edges is undirected graph is n into n minus 1 by 2. This is the mathematical ratio. This is also same since that is not same if n into n minus 1. Thus the number of edges is the directed graph is greater than or equal to n into n minus 1. In the degree of the vertex, the number of edges incident to that is the number of incoming edges. Example, in degree of 2 is equals to 1, in degree of 8 is equals to 0. Out of degree, the number of edges incident from I, that is the number of outgoing edges. Example, out degree 2 is equals to 1 and out degree 8 is equals to 2. Graph representation. For the graph representation, there are two computer representation of the graph: adjacency matrix representation and adjacency list representation. Adjacency graph, a square grid of balloon values. If the graph contains n vertices and the grid contains n rows and n columns, for the two vertices numbered I and j, then the element of the row I and column j if true if there is an edge of I to j, otherwise it is false. Adjacency matrix. Here this is the 0, 0, 1, 2, 3, 4, 1, 2, 3, 4. Here 0 is connected to 0, false. Here and 0 is connected to 1, false. 0 is connected to 2, true, true. 0 is connected to 3, false. 0 is connected to 4, false. 1 is connected to 0, like that, and so on. And the graph is totally presented like this. Adjacency graph. This is 1 is connected to 0, 0. 1 is connected to 2, 1. 1 is connected to 3, 1. 1 is connected to 4, 1. 1 is connected to 5, 0. If one node is connected to another node, it is true and its value becomes the 1. If one value is not connected to the another, its values is 0. Adjacency graph in directed multigraphs. Here this is a 0 3 0 1, so that means 0 is connected to the 1 is connected to 1 of 4 and another 3 ends is connected to the 3, like that, and second is connected to the self. Adjacency list representation. The graphs of n nodes is represented by the one-dimensional array L or linked lists, where L of list of I is linked list containing all nodes adjacent from the node I. The nodes in the list of I are not particular in order. Graph adjacency list. Adjacency list, for each vertex V belongs to V and store a list vertices adjacent to V. For example, adjacent 1 is equals to 2, 3, where is 1 is connected to 2, 3. Adjacent 2 is equals to 3, where is 2 is connected to the 3. Adjacent of 3, where 3 is directional to the nowhere. And adjacent of 4, where 4 is directional to the 3. Like this, the variation can also keep the list of the edges coming into the vertex. And implementation of the graphs. Here the P is connected to P, it is 0. P is connected to Q, 0. Like this, the graph is representation of the totally 0 and 1s. Implementing of the graphs here is also same, but A, here A is connected to B and B is connected to with the value of 8, and the B is connected with the value of the 8. Here the D is connected to the with the value of the 6. Like that, the weighted graph and the weighted undirected graph is plotted like this. Okay, this is the graph representation. Okay, thank you for watching this video.